Assalamualaikum everyone. So let's start some more example on the inverse trigonometric function. In the last class we have discussed about how to find the principal value of the given inverse trigonometric function and the domain. How to find the domain also we have discussed, and some examples, some more examples. So according to the principal value branch of the given trigonometric function, we can solve the example. So it is important for you to remember the inverse trigonometric function principal value branch. It is more important, and the domain also. If you have question on how find the domain of the given function, then you should remember that one, the domain of the given inverse trigonometric function, and you can implement this right down the solution. Okay. So see here, in the earlier we have solved for in the earlier example we have solved for the example like with just one trigonometric function. On the principal value branch of the trigonometric function for sin x cos x, we have solved such type of question in the earlier class. But here what is given to you? Here we are given find the value of tan inverse of n plus cos inverse of minus 1 by 2 plus sin inverse of 1 by 2 is 20. Means separately we have found the value for this, okay, in the earlier class. But here we have to find this term, every term. We have to find the principal value branch for each term here, then we have to add. Then we can get our answer. Okay. Now write down solution. Here the solution is, let's consider first term tan inverse of 1. It is given to you. Let y is equal to tan inverse of x. We will find the principal value branch for each term separately. Then we will add. Okay. So this becomes tan of y equal to 1. Okay. We have to write 1 in terms of tan because our question is in terms of tan. So we know that on the table value for the tan 45 is 1. So right here tan 45 in terms of radian is tan pi by 4. So it is tan pi by 4. Okay. So here it is tan of 1. This tan get cancelled. What is remaining? Y is equal to pi by 4. But we have taken y as tan inverse of 1. So write down. This implies tan inverse of 1 equal to pi by 4. This is for first term. Now take for second term, like y is equal to, consider again y, or you can consider theta also. Okay. Consider cos inverse of minus 1 by 2. See here we are having 1 in positive form plus 1. Here we are having minus 1. Here we are having this angle plus 1 half. You have to remember this point. Cos of minus theta will give you cos theta in positive form. Okay. Cos minus theta will give you cos positive. But in terms of time, tan minus theta will give you minus sin theta. So here we have to make cos such that its value remains same. We have to write in terms of radian. But if we are having cos minus half, then it will become plus positive of cos theta. In the quadrant we can see first, second, it is first, second, third, fourth. In first quadrant, all 6 trigonometric ratios are positive. In the second, sine and its inverse cosec is positive. In third, tan and its inverse cot is positive. Here, cot and sec is positive. Okay. So cos minus theta, sin minus theta will give you minus sin theta, but cos minus theta will give you, it comes on the fourth quadrant, so it gives positive cos theta. So we have to take here, if we have to take such value for that, this become cos will become remain cons, but it will give minus of half value. How? Here if we are writing pi plus theta, or we can write here pi minus theta. Pi plus theta, sorry, 90 plus theta. Here it is 90 plus theta. It comes in the second quadrant. Here it is from 0 to pi. If we are taking pi minus theta, it comes in the second quadrant. Pi plus theta also comes. Here it is pi plus theta comes in the second quadrant, and it is 0 to pi. Here we are having. So pi minus theta, it also gives same value. Here pi plus theta we are having, and 3 pi by 2, pi plus theta, 3 pi by 2 minus theta. These two values comes in the third quadrant. Here you are having uh, pi plus theta we are having here, pi plus theta. So we have to choose one value for which we will get cos of minus theta remain as it is, our value. So now consider, I am writing here cos of pi minus pi by cos of 60, we are having cos 60 1 by 2 value. So write pi by 3 cos 60. Why we are taking pi by 3? Because cos 60 is half 1 by 2. Okay. So here cos of pi, it will become 2 pi by 3. After taking out here, it will become 2 pi. Right? If you are taking 90 plus theta, here it is 90. If we are taking 90 plus, sorry, it is pi. If we are taking pi plus theta, what will happen? See, cos of pi plus theta. Why we are taking these two values? Because after taking pi minus theta and pi plus theta, we will get same cos as it is. If you are taking pi by 2 plus theta, cos pi by 2 plus theta, then our trigonometric ratio will also will change. Cos pi by 2 plus theta, then it will comes as a sine of theta. That's why we are taking pi minus theta and pi plus theta. So we are checking for both the values. Here it, after taking LCM, we will get cos of 4 pi by 3. So we have to check which value is suitable for this. Means which value is lies in between the range of cos inverse of x. We know that the range of cos inverse of x is 0 to pi, close interval 0 to pi. So this value here, pi by 3 means it is 60, 0 to pi, it will come. This value will lies in between 0 to pi. This value. This will not come lies in between 0 to pi in the closed interval 0 to pi. Here it is pi by 4, pi by 3 means it is above 0 to pi values. Okay, more than pi. 4 times pi we are having. Here we are having 2 times pi divided by 3. Here we are having divided by 4. Means 4, keep as it is, pi by 3 is 60. Then the cos to 440 we are having. Here we are having 60, 120. Cos of 120 degree we are having. So it comes under our principal range value 0 to pi close interval. So we are taking this value. Why we have write cos of 2 pi by 3? Because we are having here cos inverse of minus 1 by 2. So directly we can't write cos inverse of 1 by 2 because cos minus theta will become positive of cos theta. But in the question we are having minus sign. That's why we are taking cos of minus pi by 3. Why we are taking pi by 3? Because we know that pi by cos pi by 3 is half. Okay. So now write, understood? Always remember, you want to write cos of minus theta. If you want to write cos in terms of minus, then you have to write cos of pi minus theta. Cos minus pi minus theta will become minus cos theta. Okay. For this, you will get confused. Just for your understanding, you have to remember this two. So to make the cos of inverse of minus 1 by 2, to make cos angle as it is, we are taking cos of pi minus 3. So here we have to write cos inverse as it is. I am writing this cos here. Then it is cos y is equal to cos of, what is remaining? Here minus 1 by 2 is remaining. Okay. So for 1 by 2 I am taking cos of pi minus pi by 3, because here we are having the value as in terms of minus, so we are taking pi minus theta or pi minus pi by 3. So then after taking LCM we can write 2 pi by 3. Here cos and cos get cancelled. What is meaning? Y is equal to 2 pi by 3. But y we have taken as cos inverse of minus 1 by 2 is equal to 2 pi by 3. So we have two values for tan inverse of 1 and for cos inverse of 1. Remaining after we are having sin inverse of half. Sin inverse of half, now write that y is equal to, for the third term, y is equal to sin inverse of half. We know that sin y is equal to half 1 by 2. But on the table value for sin we have to check. So it is sin of pi by 6. Okay, sin 30 is half 1 by 2. In terms of region, it is pi by 2. Here both sides and side get cancelled. What is going y is equal to pi by 6. Okay, but why we have taken a sin inverse of 1 by 2? So right, this implies sin inverse of 1 by 2 is pi by 6. So we have find separately the each value, each term. We have solved separately for each term and we find the value as pi by 4, 2 pi by 3 and pi by 4. Now we have to write, after finding these three separately, this implies lastly tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of 1 by 2 is equal to tan inverse of 1 right value we have find it as, we got it as pi by 4 plus cos inverse of minus 1 by 2 we got plus 2 pi by 3 plus sin inverse of 1 by 3 we got it as pi by 6. Okay, now we have to take LCM. After taking LCM is here 12. Okay, so after taking LCM, 4 3s are 12, 3 5 6, 3 4s are 12, 2 4s are 8 plus 8 5 plus 6 2s are 12. Now right, I think we have to check our question as sorry, here you are having minus of, here you are having tan of minus pi by 2. Okay, sorry. So for sinus minus pi by 2, we know that it is sin minus pi by theta. Sin minus theta is, we can write sin minus, directly we can write minus pi by 6. So finally we got the value as, write one more step here. The question is sin inverse of minus 1 by 2. Sorry, it is minus 1 by 2. So write minus sin of pi by 6. So here sin get cancelled. What is remaining? Pi is equal to minus pi by 6. So here sin inverse of minus 1 by 2 is equal to minus pi by 6. Okay. So finally you got the value for this last term in terms of minus. So now write here, it is same minus, it is minus. Okay. After taking LCM, see here 3 minus 2 is 1. 1 plus 8, 9. 9 pi by 12. Here 3 3s are 9, 3 4s are 12. So it is 3 pi by 4. Our answer is 3 pi by 4. So it is simple, as we have discussed in the earlier classes. We have solved for each term separately. Here we have to find each term separately, each term, then we have to add. Then we will get the solution, answer. Okay. Now write down the another example as write down another example for this. Always remember, cos minus theta VD is positive of cos theta and sin minus theta VD negative of sin minus sin theta. Okay. So we have to write cos of minus pi, cos pi minus theta. We have to write down. Now take another example. Find the value of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Okay. So again we have to take, let y is equal to, for finding we have to find for each term separately cos inverse of 1 by 2. This implies cos of y is equal to half. We have to check the table value for cos because your question is in terms of cos. Cos 60, on cos 60 we are having 1 by 2. So write cos 60 in terms of radian, pi by 3. Okay. Cos of y. Cos get cancelled. What is remaining? Y is equal to pi by 3. For sin, y is equal to, let sin inverse of 1 by 2. So sin of y is equal to, I am writing this solution by using red marker because I think ink is finished. Okay. So here sin of cos on cos 60 we are having 1 by 2. Here we are having this on sin of 30. Sin 30 means pi by 6. So sin get cancelled. Y is equal to pi by 6. Okay. But we have taken y as sin inverse of 1 by 2 is equal to pi by 6. Now we have to write for each value separately. This implies cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2 is equal to, cos inverse 1 by 2 we got as pi by 3 plus 2 as it is pi by 6. Okay. So pi by 3 plus 2 ones are 2 3s are pi by 3. Here denominator are same, we can add directly pi plus pi 2 pi by 3. Okay. So now write down another question as multiple choice type question you are having here. Multiple choice question. I will write to it. I will write the question. Okay. I will write it.